Unified Facility Criteria Design Petroleum Fuels, August, UFC 34600, 16 August 2010. Approved for public release and distribution, unlimited. Chapter 2, General Design Information. Operational 2.1, Operational Capabilities. Design fuel facilities continue operation with using emergency temporary expeditions despite of the loss of one or more of the components of fuel, receiving the dispensing system by enemy action or other factors. The tactical mission related to the fuel facility to provide alternate sources of the fuel supply to the fuel facility to ensure emergency operation under the most adverse conditions, including backup power, emergency generators, maintain consistency with the prescribed criteria that is appropriate with the directives, instructions, and standard designs and included in NATO standards. The following specifications apply to the various petroleum fuels that may be addressed. MIL-TD, DL 5624 turbine fuel aviation grades JP4 J5 turbine fuel low volatility JP7 turbine fuel aviation kerosene type JP8 NATO F34 NATO F35 and JP8 plus 100 NATO F37 turbine aviation thermostability standard specification aviation turbines fuel oil diesel post camp stations diesel fuel biodiesel blend fuel naval distillate standard specification of canisters for kerosene, standard specification automatic spark ignition engine, standard specification aviation gasoline, avgas, and standard specification diesel fuel propellant, high density synthetic hydrocarbon type, JP10, standard specification of fuel ethanol for automotive spark ignition engines, standard specification biodiesel fuel blend stock for mild distillate engines, distillated fuels, 2.3 Fuel properties and additives. In addition with the fuel specification, refer to the Coordinating Research Council, or CRC, Handbook of Aviation Fuel Properties for the additional fuel properties following the paragraph typical physical properties of the various grades of fuel additives which would affect the design of petroleum fuel facility NATO designs and shown in fuel bracket. Alright, 231 Motor Gas or MoGas F46 ASTM D48A 14. Special precautions of the MoGas because of the high availability of gasoline provides large amounts of the vapor. Ordinarily, the temperatures combined with the tank container liquid temperatures above 20 degrees Fahrenheit. The vapor space is normally too rich to be explosive. At the temperature of 20 degrees Fahrenheit, the lower, less vapor space above the gasoline may be in the explosive range. 1 gallon of liquid gasoline would vaporize in actually 25 cubic feet of space and permitted with the escape becoming diluted with the air and high flammability provided design that precludes disposing of the MoGas in the storm or sanitary provided a design that precludes disposing of MoGas in the store or sanitary sewers. 232 Aviation Fuel Avgas F18 ASTM 8 or ASTM D91 91O. Description: aviation gas. Aviation gas, high-octane aviation fuel used for the piston Wankel engine-powered aircraft. The distinguished motor gasoline, which everyday gasoline is used for the ground vehicles, military service. Avgas is seldom used for the manned aircraft, but is commonly used for the unmanned aerial vehicles, or UAVs. 2322 Avgas 100 LL spoken as 100 low lead is most common grade for the military applications. It is dyed blue and contains a maximum of 2 grams of lead per U.S. gallon and is most commonly applicable to the U.S. aviation gasoline. Other grades are theoretically available, including grade 80, 91, and 100, grade 82, UL, and UL. Difference between all 91 and 100 LL are lead content color. The grade 82 UL is unleaded. 2323 Special Precautions AV gas. Using the wrong grade of gasoline will cause the engine problem. Virtually all grades of the AV gas available contain tetraethanol, lead, and are lead-based anti-agnostic compounds. See MoGas for flammability issues. 233 Aviation Turbine Fuels. 2331 Physical Properties Aviation Turbine Fuels. Here's a physical chart with a grade number of the JP through 4, 5, 8, 10, and JPTS, JTA, and JTA1 and hydrogenization. Properties: relatively density, specific gravity, read vapor pressure at 100 degrees Fahrenheit, maximum flash point, average viscosity, and freezing point. All right, 2332 special cost of aviation turbine fuels because of the serious consequence of the turbine engine failure. The no nature of the fuel system of the turbine guides provided with the design would include means to prevent contamination, aviation turbines, fuel, dirt, water, and other fuels. Solid contaminants are generally those which are insoluble in fuel. Most common are iron, rust, scale, in sand, and dirt. Iron, rust, contamination, aviation turbination fuel, special filtration required of receiving the aviation turbine fuel into bulk storage, operating storage, removing contaminants before fuel is delivered to the aircraft to preserve the fuel quality materials in contact with the stainless steel and non-ferrous coated with the carbon steel of the aircraft fueling system. Does not use zinc, or copper bearing alloys in contact with the aviation turbines, including piping, valves, and equipment. Accessories. The maximum air allowable aircraft serving use of the solids is 2.0 milligrams or /liters of maximum allowable aircraft service using limits of free water of 5 ppm provided with a design and precludes design disposing of aviation turbine fuels in storm and sanitary sewers. 234 kerosene ASTM D3699. Physical properties of kerosene: relative density, API gravity 51 degrees to 37 degrees, API specific gravity is 0.775 to 0.840. Rapid vapor pressure is 0.5 psi's. Flash points 100 degrees Fahrenheit. Viscosity is at 104 degrees Fahrenheit. 1 to 2 to divide 10 to 5 feet squared. Freezing point is negative 22 degrees Fahrenheit. 2342 special precautions of the kerosene designing and separate system of the kerosene to avoid discoloration caused by contamination provided with the design precludes disposing of kerosene in storm and sanitary sewers. 235 diesel sulfur content diesel fuels. Diesel fuels is available with motor fuel of the United States with low sulfur diesel or LSD, which is maximum sulfur content of 500 ppm, and ultra low sulfur diesel ULSD with maximum sulfur content of 15 ppm, both meeting ASTM D975. Physical properties of diesel fuels: automotive diesel fuel 2, diesel fuel marine, and use of low sulfur diesels. Gravity point, specific and read vapor, flash point, viscosity, and pour point. 2353 special precaution for low sulfur diesel fuels. Not as critical as aviation turbine fuels. Diesel fuels are subject to damage to dirt, water, and fuel. Avoid contamination of the dirt and water and dilution of lighter fuels in cold climates. Provided with a design to prevent the gelling, and provided with a design to preclude disposing of the disposal diesel fuels in the storm and sanitary sewers. 2354 the special precaution of ultra sulfur or diesel. With the reduction of sulfur content comes the reduction of overall lubricity. Conductive of the fuel or lubricity level can cause premature wear and damage to metal parts. And typical compression and ignition engine of lubricity of additives are added in accordance with the ASTM T975. Lower conductive can cause potential for an increase of the risk of fire explosion caused by static electricity, even though the conductive activity is added to the recommended flow rates and are limited bonding and grounding equipment utilized in minus static electricity during loading and operations. 236 burner fuel oils. 236 physical properties of burner fuel oils. You have grade numbers 1, 2, 3, 4, 5 light, 5 heavy, and 6. Density, gravity, special read vapor, maximum flash point, average viscosity, pour point, gross heat value, BTUs to the pound. Alright, 2362 special precautions of burner fuels oils. When ambient temperature of the burner fuels oil less than 20 degrees Fahrenheit above the pour point of temperature of the burner fuel oil needs to be heated. At the burner fuel oil's pour point temperature of the fuel is reached with a gel-like state and would be difficult to pump in nearly all the cases of number 6 fuel oil reheating to be pumped. In some cases, the number 4 and number 5 burner fuel oils require heating of the provided with a design to preclude disposing of the burning fuels in the storm sanitary sewers. 237 alternative fuels E85 ASTM D5798. Physical properties of E85 specific gravity 0.760 to 0.780. Rapid vapor pressure 6 to 12 psi's. Flash point negative 20 degrees Fahrenheit. Viscosity 6.1 to 10%, 10 to the negative 6 power of 3.4 times 10 to the 5th negative fifth power times fares by feet squared in seconds. Pour point is negative 200. Pour point is 212 degrees, negative 220 to 12 degrees Fahrenheit. All right. Pour point is 200. Due to the corrosive E85, the common materials used in the gasoline system were comparable to handling storage alcohols: E85 ethanol, 85% ethanol, alcohol, brass, lead, aluminum, lead-based solid, are several metals that become degraded with the ethanol exposure. Other materials include updated stainless steel. Steel, black iron, bronze seems to have acceptable resistance to ethanol corrosion. Certain non-metallic materials have been successfully used with ethanol, including the banu, neoprene, rubber, polyethanol, nylon, polypropylene, nitrile, Viton, Teflon. Common non-metallic materials degraded by ethanol are as natural rubber, polyurethane, cork, gasket material, the other polyester bonded fiberglass, laminate, polyvinyl chloride, polyamides, methylcrylate, plastic, pour cleaning of the existing tanks of the being converted with the E85 storage and required with the E85 solvent and measures properties losing tank deposits. Either the ethanol disposing of 1 micron in the line filter is recommended in impurity particle removal. The shelf life of E85 is approximately 90 to 80 days. In some cases, normal temperature E85 is less than explosive than gasoline, but E85 is more explosive than at lower temperatures. Ethanol vapors have similar behavior to the gasoline, but have lower vapor pressure. E85 is an ethical electrical conductor and potentially carcinogenic, and provides a design for the precludes the disposing of E85 in a storm or sanitary sewers for the Air Force projects, the ETL-0304. Okay, P238 alternate fuel biodiesel B20. Physical properties of the biodiesel. Biodiesel fuel B20, the blended with petroleum disposal fuel meeting the ASTM D975, and 100% of the neat biodiesel fuel meeting the ASTM D6751 and EN14214, where biodiesel content blended with is no more than 20% of the biodiesel volume. The biodiesel is physical property very similar to conventional diesel. Specific gravity 087 to 089. 0. The read vapor pressure is 0.0 psa. A's a maximum at 100 degrees Fahrenheit. The flash point is 100 degrees Fahrenheit. Viscosity is 140 degrees Fahrenheit. Pour point is 10 degrees Fahrenheit. 2382 special precautions of the biodiesel. In dispensing biodiesel, recommended with the 30 micron and the 10 microgram in line filter be used in suspension, primary or secondary means with the impurity particle. Remove the biodiesel B100 to have good solvent qualities, but will remove the deposits of the fuel system. As a result, it may require the filter changes initially. One of the most commonly used blended of the biodiesel is B20. B20 has not been approved for use of the combat tactical vehicles or equipment. The use of the biodiesel as other engines and vehicles have been reviewed for the vehicle manufacturers. Copies can be obtained with the biodiesel.org. B20 should be used with a 6-month manufacturing because of the fuel shelf life. Users should be aware that B20 blended will have an increased viscosity requirements provided with a design that precludes disposing of the biodiesel fuels into the storm sanitary train for air source projects ETL-0304. 239 liquid petroleum gas or LPG. Liquid properties of liquid petroleum gas. Liquid petroleum gas is composed predominantly of propane, propylene, and minor amounts of butane, isobutane, butanol, and odorless, colorless, non-toxic. To reduce the danger of explosion from the undetected leaks, commercial liquid petroleum gas usually contains an odorizing agent which gives off a distinct pungent odor. The liquid petroleum gas is a vapor at atmospheric conditions. It is normally stored at liquid at a storage pressure of 200 psi's, or liquid petroleum gas has the following properties: freezing point of 70 in Fahrenheit at negative 305, relatively density of 140 degrees, API, vapor pressure at 100 degrees Fahrenheit, heat content of the BTUs per pound 215591. 23392 special precaution liquid petroleum gas. Storage of liquid petroleum gas under the pressure appropriate pressure rated to the tanks. Potential fire explosion presents extreme hazard to the life property to provide adequate relief. Venting and additional fire protection in accordance with the NFPA 58. Provided tanking space in accordance with the requirements of Chapter 10 of this unified criteria. 2310 compressed natural gas. Physical properties of the compressed natural gas. Appendix A of the NFPA 52 compressed natural gas vehicle fuel systems define certain with the compressed natural gas properties. Natural gas is flammable gas. It's colorless, tasteless, non-toxic. It is light gas weighing about 2/3 of as much as the air. It tends to rise and diffuse rapidly in the air and escapes from the system. Natural gas burns in the air with a luminous flame, and the atmospheric pressure of the ignition temperature of the natural gas mixture has been reported to be as low as 900 degrees Fahrenheit. Flammable limits of the natural gas mixture's atmospheric pressure are about 5% to 15% of the volume of the natural gas. When the natural gas consists principally of methane, it also contains ethanol, small amounts of the propane, butane, hydrocarbons. It may contain small amounts of nitrogen, carbon dioxide, hydrogen sulfide, and helium, which vary from the 0 to the few persons depending on the source of the seasonal effects that distributed in the United States and Canada. The natural gas also contains water vapor. The pipeline quality gas line contains 7 pounds or more with waters per million per cubic feet of the gas subconstitute the natural gas, especially the carbon dioxide, hydrogen sulfide, with the precise liquid petroleum. Liquid water can be corrosive, carbon steel corrosive, effective with increased with the pressure for the pressure used in compressed natural gas system covered by the NFPA 52. Is substantial, well above the transmission, distribution, piping, and other natural gas consuming the equipment. Excessive corrosion can be lead with sudden explosive Reporture of container of the hazard must be controlled. Pressure of the continuous compressed natural gas fueling station are typically less than 500 psi. 2310-2 special precautions of compressed natural gas. Provided to prevent safe relief of the areas the compressed natural gas is to be stored. Compressed natural gas is high flammable substance. Therefore, designs facilities using the following precautions to prevent fires from becoming uncontrollable. Do not directly extinguish fire with water. Do not extinguish large fires. Fires to burn while cooling adjacent equipment with water spray. Shut off the continued compressed natural gas source. If possible, extinguish small fires with dry chemicals. Compressed natural gas is non-toxic and causes nausea or asphyxiation when it displaces normally at 21% of oxygen-confined area with adequate ventilation. Because of the corrosion problems with the Department of Transportation, certified tanks is limited to 0.5 pounds per million cubic feet. Information of the OTTO fuels. Information OTTO fuels is combined with the Navy C3 S6340 AAMMA 010. Technical manual of the OTTO fuel safety storage handling instruction published by the direction of the Commander Naval SEAL System Command. The distribution of the document is restricted for Navy SEAL Command handles requests of the information. 2312 lubricating oils. 2312-1 steam lubricating turbine. Steam lubricating oils or O0250 mil preference of 17331. For the use of main turbines, generally auxiliary turbine installation, central hydraulic equipment, general mechanical lubrication, and air compressors. Physical properties: flash points 500 degrees, pour point 200 degrees, viscosity of 140 degrees Fahrenheit, 80 to 104 feet times negative 10. Or 10 to the negative fifth power times at foot squared per second. 2.5 lubricating oils for use of vans designed with a high output shipboard main propulsion auxiliary diesel engines using fuel conforming with the military detailed 1688-4. 2312-3 special precaution lubrication oils to pump oil with the ambient temperature for lubricating oils less than 20 degrees Fahrenheit above the pour point temperature. Heating lubricating oil at pour point temperature, oil becomes gel-like and it is difficult to pump, ensuring the design not able to discharge the lubricating oil into the storm or sanitary sewers. 2313 hydrazine water or 8770 mil preference 26536. Hydrazine physical properties of the fuel mixture of 70% hydrazine, 30% water is clearly oil, water like liquid, and fishy ammonia like odor. Is stable with under extreme heat and cold. However, they will react carbon dioxide, oxygen in the air, and it may ignite spontaneously with the contact of metal oxide such as rust. 2313.2 special cautions to 870 to keep working with storage areas, cleaning of the free with materials that may react with hydrogen, provided with the stainless steel areas with their extended contact as possible, areas with their indicated incidental contact as possible, and should be kept free of the rust. Ensure the design does not allow discharge of the 870 in the storm waters and sanitary sewers. All right, 2314 fuel additives. 23141 fuel system ice inhibitors, high flash, detailed 85470 diethyl glycomonomethyl ether. Used aviation turbine fuels, preventing the formation of ice crystals trapped in water. The fuel at unfreezing temperatures, in addition to the good biocidal properties, preventing growth of microorganisms in the fuel, and avoid water entry bottom to the storage tank between the additives that will dissolve water, reducing the concentration of additives left in the fuel. Refer to the fuel specification for more information. Consult the federal, state, and local regulations, appropriate disposal methods. 23142 corrosion inhibitor lubricosity improver, the military preference of 25017. The combination of lubricosity improve the corrosion inhibitor activity procured under the military preference 250117 is injected with the military aviation turbine fuels as refinery in order to improve the lubrication characteristics of the fuel. 23143 static dissipator and additive. Static dissipator additives (SDA) enhances the safety during the handling of the flight and by reducing static discharge potential in the vapor space above the fuel. The static dissipator additive increases the conduct of the fuel and decreases the electrostatic change of the relaxation time. The rate of the charge of the dispo aids the travel through the fuel, which decreases the potential for the ignition from the static charge of the actual proportion of the accordance with the specific fuel military specification fuel system for design purpose, assuming the lower limit of 50 pico Siemens per meter and the determination relaxation requirements. The static dissipator additive is added to all JP8s, F-34, F-35, and F-37. The static dissipator additive is not added to JP5, F-76, F-76, or Jet A and A-1. This is stored in military installations. 23144 the thermal stability improver additive, or plus 100 additive. The thermal stability additive, TSIA, enhances during the handling of the flight and increases the fuel tolerance of elevated temperatures. GP8 1 plus 100. GP8 1 plus 100. NATO 537 is the aviation turbine fuel for the TSIA. Alright, product segregation. 241 product grades. Except otherwise, service headquarters provided with a separate receiving, storage, distribution systems for each product, except otherwise approved by service headquarters, preventing misfueling, transferring a type of fuel other than the type intended by using different size piping valves, adapters, nozzles, etc. The products to be segregated into monogas, diesel fuel, including ultra sulfur diesel or distillated type burner fuels, aviation turbine fuel systems such for each grade, residual type of the burner fuels number 4, 5, and 6, liquid petroleum gas, compressed natural gas, OTTO fuels, E80, ethanol 85, biodiesel, E80 and 242 exemptions designed for the differential product for the same of the piping may be approved with long receiving lines such as tanker barges, piers, cross-country pipeline storage facilities where some common occurs but makes provisions receiving segregation of the interface between the two products. Consider the use of pigs and brakes. Use of pigs or breakout tanks for the separate batches. Exemptions will be approved for the common system to carry both cleaning and residual type fuels. 2.5 transfer fuel flow rates. Table 2 shows the recommended range for the design flow rates. In some cases, the greater the rates may need to meet operational requirements of a particular facility. These are design flow rates for aviation turbine fuel designs, burner fuels, and oils and mogas under each storage, different storages. 2.6 physical security. Plan to design fuel facility with the global protection of the fuel storage and transfer capability. An enemy attack, terrorists, and sabotage, fire, systematic activity, or other damaging influences. A high threat area, more extensive the protection may be required with the consult appropriate service headquarters for guidance. The NATO projects have either their own specific criteria which govern the protection level requirements. 261 anti-terrorism physical security. The per DoD 5200 series .80 .08 R physical security program and minimum fuel support points, pipeline pump stations, piers shall be designated with the post-controlled areas. Also, controlling criteria assets may be designated as restricted area. Controlled restricted areas are found and defined in the with which they are specifically restricted. The measures employed with the preventive and unauthorized entry. Restricted areas may be of two different types depending on the nature of the varying degrees of importance protecting the assets. The restricted asset areas must be authorized by the installation commander, properly posted, and shall employ physical security measures. UFC 402001 DoD Security Engineering Facilities Planning for the Manual, supporting the planning of the DoD facilities required that include requirements security and anti-terrorism used in conjunction with the UFC 401001 DoD minimum anti-terrorism standard for buildings to establish security anti-terrorism design criteria that will base on the Department of Defense facilities. The UFC 401001, the DoD minimum anti-terrorism storage building establishes standards provided with the minimum levels of protection against the terrorist attacks of the occupants of all DoD inhabited buildings. Incorporated with minimum standards, it is designed for the new construction, many renovations of the inhabited Department of Defense buildings. Coordinated with the installation, activity, security, anti-terrorism office to determine areas of distinguished control, restricted the threat, and environmental design basis of the threat, level protection, and access control requirements. Alright, 262, security fencing. Unless otherwise directed with the service headquarters provided with the security fencing around all the patrolling facilities to ensure safety, inhibited sabotage, threat, vandalism, unauthorized persons. Install a 7-foot fabric height fence of the chain link type with the 3 stranded barbed wire outriggers on top of the equivalent, ensuring the fencing gate associated clearance requirements in accordance with Military Handbook 1013-10 or UFC 402003 FA. Contact Installation Security Organization for additional requirements. 27. Maintainability capability to provide adequate maintenance space around all equipment, including filter separators, other filterization devices. Maintain access, particular element removal for vertical filterization devices provided with a stair and platform access to at least one of each side of the unit. Manual valves, especially replacement of slips of double block and bleeded, tapered, lifted plug valves. Adequate room location used for the intelligent pig launcher receivers in all section of piping. Metal meter reading and maintenance control valves, pumps, including removal instrumental, especially the mounted on tank shells. 2.8 Voice communication. Provided with the voice communication direct line of Air Force projects only between separated such that the receiving, dispensing, pumping station, fuel storage areas are coordinated with the operations involved with fuel transfer for the UFC 350101 or the UFC 3550-01 Corps TM 581109. Other communication. Data communication shall be designed in accordance with the applicable Telecommunication Industry Association (TIA) and Electrical Industrial Association documents. Coordinated with local base communication squadrons with applicable for Army, Navy, Force Communication Systems Design Criteria. See USA, ETL 11-10-3-502 Air Force, LTA, AF, DOD, UFC 35801. Alright, 292, fire alarm communication. Fire alarm communication should be considered with the base of the fire department. The fire alarm communication system requirements. See the relevant UFGS. 210, vapor recovery. Provided the vapor recovery were required by the federal, state, and local regulations. Title 40 CFR Part 60, Subpart 20. Other chapters of the UFC refer to the paragraph of the air quality control in Chapter UFC. 211, work safety design. Facilities comply with the most stringent occupational safety hazard health administration or host nation standards. Also ensure the design complies with service-specific occupational safety and health criteria for national OPNIVS AVS 5123 series applies. 211.1 Safety showers at the eyewash fountains. The safety shower eyewash facilities are required with workshop, laboratories, pump houses, fueling piers, and other similar facilities. Fixed safety showers and/or eyewash portable eyewash units shall be installed with the other locations where the fuel is transferred to and from the trucks and rail cars and aircraft. Refer to the Appendix D for the UFC 42001 plumbing system for additional requirements associated with emergency showering and eye stations. All right, 212 electrical design, 212.1 area classification of all fuel facilities except as modified by UFC is accordance with the API API RP 500, NFPA 330 and 70, NSI IEEE C2. The practical modified where the unusual conditions occur with locations containing hazardous atmosphere classified other than Group D as defined with native NFPA 70, where the equipment of malfunction can cause a hazardous situation and use sound judgment in applying the requirements of specifying the higher classification when necessary to maintain safety and continuity in service. Treat combustible liquids under pressure as flammable liquids. All piping and equipment included connected to the atmospheric storage chain shall be considered with the pressurized. Ensure design in accordance with the requirements designed with the NFPA 70 for the specific divisions and class. Ensure the equipment temperature, class, or operating temperature in accordance with the NFPA 70. And ensure the project drawings, including the hazardous areas and indicate the extent of the classification of areas. Drawings should be provided with the dimensions indicating extent. Classified areas should include the section to elevations and required for the full convoy to that extent to the area. 212.1.1 Class 1 Division 1. Class 1 Division 1 includes locations include outdoor location out and indoor locations that have positive mechanical ventilation that was within 3 feet of the on the filling of the openings of the individual containers to which flammable liquids are being transferred, provided with alarm device on all ventilation systems, or outdoor locations within 5 feet of the open end of the vents, open liquid for storage tanks extended in all directions, entire pit, summon, up trench, other depression, any part of which the Division 1 or 2 location with other mechanical ventilation location within exterior walls to the open top of the spill contaminant structures, including oil, water, separators, spill contamination boxes, locations at fuel dispensers, locations within 3 feet of the vent extending in all directions when loading and trucking at the bottom of the connection, all pumper filter houses handling liquid fuels, any area containing electrical equipment that is and may be exposed to atomized fuel and within ambient temperature can be any time above the flash point of the fuel. 212.1.2 Class 1 Division 2. Class 1 Division 2 include or there are locations between 5 to 10 feet over the Division 1 zones at vents of opening liquid fuel, storage tanks extending in all directions, entire pit or open trench of the depression, any part of which within Division 1 of the 2 are located provided with mechanical ventilation, outdoor locations of the 3-foot exterior surfaces, pipe, air relief valve, the withdrawal filtering meters, similar devices located with the pipelines handling liquid fuels under pressure were Class 1 2 divisions, extended upward at 18 inches above the grade level within 10 feet of the horizontally with any surface of the device. Location while with extending upward of the top of the dikes surrounded up above grounds containing liquid fuels within 10 feet of the 3 meters extending in all directions of the tank shell and end or roof. Location extending upward to 18 inches above the ground level above within 15 feet of horizontal any surface of the open top spill and contaminating structures including oil, water, separators, spill contamination boxes whether installed indoors or outdoors. Location 25 feet of the horizontally in all directions on the pier aside from the portion of the hull containing the cargo from the water level to 25 feet is above the cargo tank. The highest point areas between 3 feet and 10 feet extending in all directions from the vent when loading the truck. Also upward 18 inches above the grade and within 10 feet of horizontal from the truck of the load connection. 213.1.3 non-classified locations. Non-classified locations include outdoor locations having closed pump line piping systems having flammable combustible liquids having no pumps, air relief valves, withdrawal fittings, valves, screw fittings, flanges, meters, similar devices which create joints at the pipings, office building, boiler rooms, control rooms, similar locations that are outside the limits of the hazard location as defined above in the not are the used for transferring flammable combustible liquids containing such liquids, areas and flammable combustible liquids are stored in accordance with the NFPA 30 outside the limits of a classified location or liquids are not transferred. 212.2 Illumination all working areas for the night operation minimum intensity recommendation table 4 API RP 540 light design should also provide with the road access tail light to also allow for lamp replacement for facility with the jurisdiction for the U.S. Coast Guard under 33 CFR Part 154 illumination minimum intensity required by the regulation provide security lighting in accordance with the Military Handbook 1013-1 for the Navy UFC 550 035AA, 035FA, the Army and Air Force AFOSH Standard 9138 for the Air Force if the local state and regulations exist, follow the most stringent requirements. Alright, ground and bonding. The following references apply to grounding and bonding system NSI IEEE 142, NFPA 70, 77, 7800, NFPA 780, API R 540, API RP 2003, NSI IEE 1100, NFPA 407. Alright, 212.3.1 grounding requirements. Grounding the following items in accordance with Article 250 for the NFPA 370 when the motor generator transformer frames, non-current carrying metallic parts for the electrical equipment of the installation such as enclosure, panel board, switch gears, and motor control centers, metallic messenger self-supporting cables. Exposed conductive material includes with electrical conductors such as metallic conduit, metallic tubing, metallic arming, sheaths, shields, cable troughs, trays, racks, wireways, busways, filter separators, and other filter equipment. 212.3. 2. Current light protection. Provided with light protection in accordance with Corps TM 581.3, AFM 88.9, NFPA 78.0, Military Handbook 1004-6, locational installation requirements for fall current protection, lighting protection, ground the following items through ground rods or beds bonded with the ground network provided with the ground that these items are required by the above reference. Fencing, lighting resistors, lighting arresters, and lightning shields or conductors, operating mechanisms, overhead air brake switches, canopies, above ground storage tanks. Alright, 212.3.3 static electricity prevention. To prevent buildup of static electricity, ground the following items directly through the ground rods or beds to the ground and network. Do not exceed 10,000 ohms of resistance to the ground unless otherwise stated. Do not bond dissimilar metals together. Above ground tanks, vessels, stacks, heat exchangers, similar equipment do not directly support bolted to the ground supporting network. Pipe and pipe support columns in accordance with the more stringent NFPA 77 or below. Provide minimum of one ground rod and the pipe runs with 100 foot or long or less unless the pipe is connected with the ground source within 100 feet. Provide a minimum of 2 ground rods on the runs of the pipe that exceeds the 100 feet but are less than 300 feet in length. Provide a minimum of 1 ground rod at intervals not exceeding 300 feet on the runs of pipes that are greater than 300 feet in length. Parallel pipes or may be ground bonded or common grounds are used as spaced in accordance with 1 or through 3 above. Aircraft direct fueling stations, hydrant pits, internal floating pans bonded to the storage tank shelves, above ground portions of electrically isolated piping at the truck and rail, marine loading and unloading stations. 212.3.4 installation, isolation grounding system for instruments, instrument control panels, electronic equipment for other ground systems. Additional grounding is not required for the overheated electrical bolt directly to the ground and metallic sources, whether feasible or separated with the conducting connection with the lightning rod to the grounded electrode from other ground conductors. Route of the minimum sharp bends in the most direction manner for the grounded electrode. Do not use this electrode in lieu of the grounding electrodes, which may require by other systems. The provision does not prohibit the required bonding together for grounding electrodes for the different systems. 213 cathodic protection. Obtaining service of National Association of Corrosion Engineers certified or NACE certified corrosion specialist, cathodic protection specialist, or registered professional corrosion or engineer to perform all cathodic protection design and testing for Army and the Air Force. Design comply with the current engineering technical letters and additional with the following requirements for the Navy. Design compliant NAVFAC interim technical guidance FY 9401. 213.1 tanks for ungrounded the steel tanks and tank bottoms of the above ground vertical tanks provided with the cathodic protection in accordance with the UFC003 API RP 651-40 CFR Part 280 UL 1746 UFC 34603. For additional information on the cathodic prevention refer to the Navy FAC MO230 AFI 232-1054 for current tank designs, configuration, electrical isolation tank bottom of the surrounding earth. Therefore, install the cathodic protection between the liner and the tank bottom. 213.2 piping for all the carbon and stainless steel underground and underwater piping. Provide cathodic protection in accordance with the UFC 3570029 and for the Title 40 CFR Part 280 for the piping associated with the underground storage tank. For the additional information for the cathodic protection, refer to the Navy FAC MO 230 with the NACE SPO 169 control external corrosion of the underground submerged metallic piping system in Title 49 CFR Part 195. Buried stainless steel corrodes and therein must be cathodic protection. 213.2.1 surge arresters. Provide surge arresters across all the above the ground insulated flanges connected with the below ground cathodic protecting pipe, requiring surge arresters to be designed for the use of the insulated flanges for use of Class 1 Division 1 areas and provide covers for Flanges to preclude dirt and degrading surge arresters, referring to the Department of Defense Standard Design AW78 24828. 213.3 Obtain services of the NACE Certified Corrosion Specialist, Cathodic Protection Specialist, a registered professional corrosion engineer to evaluate the need of cathodic protection on the steel portion of fueling the support facilities. Comply with the UFC 029. Environmental protection. 214.1 General policy. Firm policy of the Department of Defense to design, control, and construct fueling facilities in a manner will prevent the damage of environmental accidental discharge of the fuels and their vapors. Residual design must comply with the foreign government, national, state, local environmental protection regulations that are in effect in the particular facilities. 214.2 Regulation 214.2.1 Within the United States, with the jurisdiction of the United States adhere to the following environmental protection regulations: National Environmental Policy Act, Title 49 U.S. Standard Code 4321, U.S. Coast Guard Regulation 33, Code Federalization Part 154, Environmental Protection Agencies Title 40, CFR Part 60, 122, 122, 112, 122, 280, 281, Department of Transportation Regulation Title 49 CFR Part 195, obtain additional and data any anti-pollution regulation for specific location, service headquarters, environmental support office. 214.22 Outside of the USA, all facilities out of any other countries consult appropriate service environmental directive of the Department of Defense, overseas environmental baseline guidance doctrine of the Navy, Op Navius Instruction 50901, for the appropriate address for the Department of Defense, overseas environmental baseline guidance document appropriate with the final governing standards of the region, country, and the tank to be installed with the local state and within more than stringent criteria of the use of most stringent criteria. The tank is to be installed with the NATO country other than the CONUS. Follow the most stringent local regulations of the NATO airfield standard designed for the jet fuel storage and dispensing systems. 214.3 Transfer of fuel at ports. 214.3.1 Bulk transfer. Compliance with the Title 33 Code Federalization Part 154 is required for each fixed facility capable of transferring fuel in bulk to form a vessel with a capacity of 10,500 gallons or more. The facility is required to have an operation manual approved by the captain of the port. In this operation manual, they include the requirement for the following systems: hose assembly, loading, arms, closing devices, monitoring devices, small discharge, contaminant discharge removal, discharge, contaminant equipment, emergency shutdown, communications, lighting. 214.3.2 The vapor collection. The facilities for collecting vapor with the vessel cargo tanks ensure the requirements of the Title 40 CFR Part 60 for the following items are met: vapor line connection, vessel liquid and overfill protection, vessel vapor overpressure, vapor vacuum protection, fire explosion detonation protection, detonation arresters, flame screens, an air enriching diluting system, vapor compressor, blowers, vapor recovery, and vapor destruction units. What do we got? Title 214.4 Air Quality Control. 214.4.1 Designing Requirements. Regulatory requirements pertaining to the air quality control will vary according to the locality, to the type and size of the petroleum vapor source, the petroleum storage and dispensing facility, or common source of the air pollution, the emission of the typical restricted through requirements in state and local regulation, federal regulation. Title 40 CFR Part 60 subparts KB and XX may also be depending on the product of the handle, but the size of the tank of the facility being constructed. 214.4.2 above storage ground tanks. Federal regulation Type 40 CFR Part 60 subpart KB requires for these tanks to be stored with the fuel design capacity greater than 19,000 gallons, having the true vapor pressure greater than 0.75 psi's at the operating temperature, must be equipped with either one of the fixed roof or the combination with the internal floating pan, external floating roof equipped with a dual seal closure device between the wall of the tank and the roof edge. 3. A closed vented system designed to collect all volatile or organic compound vapors, gases discharged from the tank of the control device, designed to reduce the VOC emissions by 95% and greater. If the design is intent with the most vertical above ground tanks will have internal floating pans. The vapor recovery will be used only if required by the federal, state, and local regulation for the type of the fuel or the tank proposed, and except if specifically required by another chapter of the UFC. Refer to Chapter 8 of the UFC, the Unified Facility Criteria for specific requirements for floating pans. Alright, 214.4.3 Truck and railroading facility. Truck and rail loading facilities. Tanker truck and tanker car loading facilities constructed modified after the December 17th, 8th, 1980 will load on an annual average of more than 20,000 gallons per day of the fuels having true vapor pressure of 0.7 psi's or kPa 5 kPa psi's. The grader must discharge the vapor resulting from such operation in a closed system, ensuring the system leads to vapor recovery. The disposal system is capable of removing 95% of the petroleum vapor before final discharge in the atmosphere. Equipment bulk or gasoline terminals handling fuel with the true vapor pressure of less than greater than 4.003 psi's, with a vapor collection system designed to collect total organic compound TOCs or vapors displaced from the tank trucks during loading. Emission from the vapor control system due to the load not exceeding 35 milligrams of total organic compound per liter of the gasoline load. The facility with existing vapor and processing system, the total organic compound emission must not exceed 80 milligrams of the total organic per liter of the gasoline load of the Title 40 CFR Part 60 Subparts 20. Alright, 214.4 permits required. All air quality permits are typically required for the construction, petroleum storage, dispensing facilities. It's essential for the designer to review the regulatory requirements, ensuring the incorporation proper environmental control. State and local regulations are primary sources of the air quality requirements for both but particularly large facilities. It also is beneficiary to confirm with the EPA regional office the permit, the review, and the air quality control further depend on whether the construction site is located in the attainment and non-attainment areas zone of the different permit programs apply in these areas, but they can both yield for the strict control requirements depending on their air quality of the air. Any emission offset analysis may be necessary beyond any of the construction permit can be granted. The analyze will require to demonstrate the reduction of the VOCs emissions, and other sources of locality where their new construction is taking place. The offset can be obtained with the provided new or better controls, but otherwise decreasing the emissions but for an existing source. 214.5 Water control, quality control. Design requirements protection from the natural waters against pollution for the discharge of petroleum is achieved with complying with the federal, state, and local regulations. 214.52 Stormwater discharge, the National Pollution Discharge Elimination System. The permits of the Title 49 CFR Part 122 may be required for the discharge of the stormwater. A review of the federal, state, and local stormwater regulations required prior to the design of the construction and discharge of the stormwater includes controlled drainage of the storage tanks, areas, impermeable, stacked, enclosure drainage system leading to impoundments, drainage, and the treatment system drainage of the facility, transfer, operation, pumping the tanker car, truck loading and offloading areas, drainage of the equipment for the vehicle maintenance areas. Let's see, 214.53 Spill Prevention Control Countermeasures Plan. The minimum requirements of spill prevention in the United States are contained in the Title 49 CFR Part 112 that requires the preparation of the Spill Prevention Control Countermeasure Plan for the facilities that may discharge and fuel to navigable waters in the United States. Specific design of the features are necessary to meet the specific spill prevention control countermeasures objectives at all facilities. The spill prevention control countermeasure plan must be demonstrated the fuel facility will be designed with construction in a manner that will prevent the spillage. If such a spillage occurs, preventing the spill of leaving the property and entering the waterway, reviewing the API Bulletin D16 to assist the conformance with the regulation. Further, Title 33 CFR Part 154 of the small discharge containment. 214.54 Meeting the Spill Prevention Control Countermeasure Plan Objectives. Title 49 CFR Part 112 allows the spill prevention control countermeasure plan to objective to meet them all by either the spill contaminant spill treatment for other facilities covered by the UFC. Only the spill contaminant systems are acceptable. Spill treatment systems should not be allowed to meet the spill prevention control countermeasure requirements unless they are required by regulation, provided that the treatment system and oil, water, and separators of the treatment of the discharge for the spill contaminant system only when required by the federal and state. Local regulations or service headquarters. Typical facility requiring a spill contamination system are the air or fuel storage tanks, tanker truck loading, offloading, and parking areas, and tanker car loading and offloading areas. 214.5 and 5. Spill contamination system. The spill prevention contamination and countermeasurement plan objectives are expressed in Title 49 CFR Part 12 shall meet the impermeable spill contamination system designed to prevent the spill from leaving the property unless the spill treatment system is required by the federal, state, and local regulation service headquarters. See individual chapters of the Unified Criteria, Facility Criteria Requirements. 214.5.6 spill treatment and waste spill treatment systems or oil water separators. Treatment systems or oil water separators may not also be used to meet the requirements of Title 49 CFR Part 112 unless required by the federal, state, and local regulations or is determined by an appropriate service headquarters. Do not provide oil water separators to treat discharge from spill contamination systems, secondary contaminant dikes, tank, trucking, parking areas, loading, offloading facilities unless specifically required by the regulations. Select either conventional or rectangular API gravity oil water separators or other than one inclined parallel one of the inclined parallel plates, whether possible, design the separator or rectangular vessels or with fully open top and lid with the ease of the inspection of the cleaning. Alright, design construction of the separator in accordance with the following: UFC00301, UFC0030101, USG FGS 444253, Army Corps Engineering, ETL 1110-3466, ACI 350.4R04, the design consideration environmental engineering construction, engineering concrete structures. Considering the following items in sizing the oil water separator: anticipated inlet flow of a 5-year to 1 hour duration storm event, and typical type of fuel, specific gravity, viscosity of the fuel, specific ambient product, temperature ranges, product storage capacity required, possible contamination present, operating parameters, and terminate with continuous. Require parallel plates to be constructed with non-allophobic materials such as fiberglass arranged with the plates in either downflow, crossflow modes such as oil collects in the high point of the corrugates rise at the top of the clogging from settable solids. Considering installing the retention basin upstream of the oil water separator, this would also solids to settle prior to the reaching the oil water separator. All out of the options either releasing the storm weather or the oil water separator to appropriate storm water collection systems. Alright, 214.5.7 leak detection as required by the federal, state, and local regulations. Install leak detection on above the ground tank bottoms and underground storage tanks and underground piping. 214.5.8 wastewater disposal provided the holding tank of the wastewater is any water which has been in contact with significant quantities of the fuel, such as water collected with from the tank sumps, equipment drains, and equipment sumps, and ensuring the tank of the construction forms the federal, state, and local environmental requirements provided with the means to remove the wastewater of the off-site disposal. 214.5.9 dewatering. When dewatering and the construction purposes necessary to the contamination suspected, the test on the groundwater prior to the construction to determine the extent of the contaminate with the groundwater is and has the potential to contaminate with the petroleum products. Review the federal, state, and local regulations for acceptable treatment methods. Permits may be required for the treatment and other disposal of the water. Contact facility environmental department of the guidance. 214.6 above ground storage tanks. 214.6.1 designing requirements. The above ground storage tanks may be single wall, double wall, horizontal, vertical, protected with fire resistant as described in Chapter 8. There is no signal federal regulations specifically addressing the above ground storage tanks, and similar to Title 49 CFR 2 the solely governs the underground storage tanks. The majority of the federal environmental guideline requirements come from either the Title 49 CFR, Title 40 CFR Part 112, the Title 29 CFR Part 1910 and 106. These regulations include environmental related requirements for diking, drainage, floodage, corrosion protection, inspection, detection, test records, brittle fracture analysis. The design must consult with the latest version of these regulations, comply with all the federal, state, and local regulations. 214.6.2 other requirements: if the tank is to be installed with locale, state, and more stringent criteria with the use of the stringent criteria. If tank is to be installed in the NATO country other than the CANAS, follow the more stringent local regulations of the NATO airfield standard design jet fuel storage dispensing systems. 214.7 the underground storage tanks. 214.7.1 design requirements: all underground cut and covered to the storage tanks with double the wall type. The single wall underground storage tanks are not allowed with the floor underground storage and larger tanks of the 110 gallon. The following are required in Title 40 CFR Part 280. The corrosion protection of the tanks associated with underground piping, high level alarm, spill and overfill protection, release and detection. 214.7.2, the other requirements, if the tank is to be installed with locale and state with the more stringent criteria, the use of the more stringent criteria, the tank is to be installed with a NATO country other than the continent of the following. Follow the most stringent local regulations, the NATO airfield standard is line jet fuel storage dispensing system. 215 Fire Protection. 215.1 General requirements designing all petroleum fuel storage, handling, transportation, distribution facilities with the fuel, consideration of hazardous nature of the fuel to be handled with these vapors, ensuring the compliance with the UFC003 215.2 Protection of above ground storage tanks. Tanks is a secure fire protection water system, provide fire protection water mains, hydrants, valve pumps, application devices, permit control brushes, grasses, fires, coolings of the storage and the event of the area of exposure to provide a minimum of 2 hydrants located with the hydrants available outside of the dike areas accessible to the fire department, pumper vehicles, the local hydrants so that the protected exposures can be reached through the hose run, not exceeding 300 feet, to comply with all the requirements of UFC 3601 water supply. 215.2.2 Tank Interior Fire Protection System. Tanks containing Class 1 flammable fuels, mission critical Class 2 combustible fuels such as JP8 shall be equipped with a full contact aluminum honeycomb floating pan. Other classes of the 2 require a floating pan if the storage does not comply with the spacing and the diking requirements of the UFC. The tank storing the mission critical Class 3 fuels such as JP5 and diesel fuel marine F76 is located with the hot desert-like climate. It is also required the floating pan to eliminate the fuel air interface. It is single-slotted stilling well. This penetrates the floating pan with it has a maximum diameter of 10 inches and is used in an automatic tank of the gauge system. It is also provided with a vapor sleeve below the slotted well. Use the manual measurements shall be equipped with the floating plug. 215.3 Fire Protection Pumping Facilities. The fuel pump house, wherever the 50% of the fuel hydrant pumping capacity is one fire area, the others are enclosed, should be protected with the automatic fire suppression system, such as fire sprinkler system, foam water fire suppression system, etc. Fuel pump houses with over 50% of the transferring pump is in one enclosed with the fire area should be protected with an automatic fire suppression system. Foam water fire suppression system readily available with mobile pumping equipment within 50% of the total pumping capacity. These can be used with eliminated need for the fire suppression system when the mobile pumping option is selected to provide connection points in the fueling system, the temporary mobile points in the event of the day, and event that the pump facility is lost. The pumping pads and the pump shelters do not need fire suppression systems. 215.3.1 Pump houses, pump shelters, and pump pads. Pump pad has no roof or the canopy. The pump shelter has a roof with at least one wall completely open with the adequate fire department access. The total open air wall area of the 50% or more. A pump house has a roof with the total open air wall area of less than 50%. 215.3 The fire department access provided adequate fire department access with all the pumping. The facility provided with the fire department access to all open sides of the pump house and the pump shelter provided with the fire department access to at least 2 sides of the pump pad. 215.4 for the fire protection underground vertical storage tanks. The 215.4.1 fire protection water system provided for fire protection water main hydrants, valve, the pump station, application devices permit the control of the brush and grass fires for cooling and above ground piping equipment associated with the above ground vertical storage tanks. In the event of the fire with exposure, provide a minimum of 2 hydrants located with the hydrants so they are protected. Exposure can be reached through the hose of the runs not exceeding 300 feet, complying with all the requirements of the UFC 300 and 600-01 for the water supply, except for the minimum of the fire flow rate. Minimum duration per hydrant shall be calculated using the smallest diameter of the above ground petroleum oil lubricant tanks. 215.5 Petroleum of the tanker truck air tanker car facilities. For facilities such as loading stands using the transfer flammable combustible liquids or from the tanker truck, 3 fuelers, tank cars, the drums, or other portable containers provided with a portable dry chemical extinguisher, appropriate size, number, and location for the exposure. 215.6 Protection of aircraft facilities provided with the firefighting equipment in accordance with the service requirements for the USAF AFTF 003 25172 Navy Air 0080 R14 Navy Air 0080 T109 AR 420.90 NFPA 407 All right, year 215.7, the protection of fuel testing laboratories. Laboratories should comply with the general facility requirement of Title UFC 360.01 and the NFPA 40. Laboratories using chemicals. 215.8, the protecting support facilities comply with the TUFC 360.0 for the fire protection of the support facilities. 215.9, for the protection of fuel pilers. Provide protection for the pilers for the fixed piping system using the transfer of flammable, the combustible liquids in accordance with the following: UFC 36001, UFC 4 15201, UFC 4 15002, UFC 4 15006, and FPA 380A 307 if the liquids are handled with bulk quantities across the general purpose of peers and waivers. 215.91 fire protection water system, fire water system hydrant located with such a vessel along the sides. It can be reached through the hose lines not larger than 300 feet. Consult with the UFC 600 to determine the total water demand for the piers based on their extra hazard occupancy and classification. 214 emergency shutdown. Emergency fuel shutoff push buttons are required whenever there is a potential of accident relief. The EF on the emergency fuel shutoff push button stations is required with the nearest tank at the outside of the boat room area, the tank of the tanker, the tank of the car, and the tanker truck loading and offloading. Refuel their fuel. Truck fill stands of the aircraft, defueling the fuel station pump and the fuel pillars. All the pump shells shut down and all the motor operated valves are closed. But the emergency fuel shutoff button is pressed, an alarm shall be initiated with the master alarm panel operating. All pumps and the valves shall be discontinued until the emergency fuel shutoff push button are cleared with the alarm. Acknowledgement offshore pipeline basis receipt of the tanker's receipt with May exemptions. Contact the service headquarters for the direction. Alright, 217 electromagnetic radiation hazard. Potential ignition hazard for petroleum storage, dispensing, and handling facilities may be created by the emission of electromagnetic devices such as radio or radar. Beam signal strength has been known to cause significant flammable vapor, air mixtures, the inductive electrical heating of the solid materials for electrical arcs, and sparks with the chance with resonate connection. For additional information, refer to the Military Standard 461 for the NFPA 407 and incorporate the following specific precautions, restriction, and design of petroleum facility. Locate the radio transmission antennas as far as the practical possible for the fuel storage and the transfer areas. Do not locate the fuel transfer facilities closer than 300 from the aircraft and warning the radar antennas. Do not locate the fuel storage at the transfer facility closer than 500 feet from the airport ground. With the approach for the control equipment, do not locate the fuel storage transfer facilities closer than 300 feet from the areas when airborne with the surveillance radar may be operated. Do not locate the fuel storage and transfer facilities closer than 100 feet of the airport surface of the detection radar equipment. 218, the identification of all pipeline tanks and also production surface producing the color banding of the product, the name, the NATO designation, direction of the flow in accordance with the military standard 161, mark values, the pumps, meters, and other items, equipment with easily discernible paint numbers and numbered corrosion-resistant metal and plastic tags attached with a suitable fastener. Ensure the number that corresponded to the schematic flow diagrams other than the drawing for the installation. 219 anti-static design. Consideration static built up in the design. Refer to the CRC report number report 346 3455 API RP 2013 Navy Flak Mo 230. Because of the Army, those main variables included such as properties, fuels, and geometry of the equipment layouts. No specific elements are established for design factors such as flow velocity. 219.1 piping inlet connection. The design and connection tanks with reduced velocity of preventing splashing by using diffusers. The fuel products are not permitted to free fall under any circumstances. Position inlet as close to the tank of the floor as possible to limit the free fall. 219 enclosed vapor spaces. Spaces above the flammable combustible hydrocarbons in the tank. Other liquid containers must have been any pointed protection probes which could be focal points of static electrical discharge. 219 filter separated. The heaviest electrostatic charges are usually developed in filtering elements of the equipment designed for the charge to be attached to reduce such as charge before the fuel is transferred in the storage tanks, vehicle tanks, and equipment containing the vapor source. by means of residence time of the piping and the relaxation tank provided with a minimum of 30-second relaxation tank between the equipment of the discharging into the tank of the vehicle, and only aviation turbine fuel currently is in inventory that requires the minimum relaxation time of the JP5, the GPTS, and other aviation turbines that do not contain the static discharge, the SDA. Relaxation type of the design required for the project's handling only fuels the static dissipator additive that provides the conductivity level greater than 50 conductivity units with 50 picosecond per meter at the fuel temperature of the operation. Example, the JP4 and JP8. Provides a means for slow filling of the preventing static discharge when filling. First filling the empty filter separator vessels 219.4 aircraft directing fuel station. The JP5 requires a 30-second residence time in the piping or relaxation tank after following the filterization before being discharged into the aircraft to allow separate charges generated from the filtering elements to recombine with neutralizing themselves. Where possible, design with the piping layout to provide with the required 30-second relaxation time without the relaxation tank. 219.5 the truck bottom loading provides facilities incapable of the bottom loading of the trucks. Army facility routinely handled the tanks. Trucks and not capable of the bottom loading must be obtained approval for the obtained additional top loading capability of the Army Service Headquarters. Refer to the NFPA 77 API RP 2003 for additional information requirements. I gotta take a piss. Operation maintenance documentation. Equipment operation maintenance documentation. In all construction procurement contracts require the operation maintenance data and the piece of the equipment with requiring maintenance and/or requiring settings, adjusting, starting, stopping, calibration system, similar operating activities. 220. The operating maintenance support and information. The OMS operation maintenance support information and OMSI. All new facilities is required. Determination if included a requirement for the complete operation maintenance support information for the new facilities. Major rehabilitation made in the appropriate service headquarters. 221. The project against somatic activity, design, fuel fielding, structure, and somatic requirements in accordance with the UFC003 design above vertical storage tanks in accordance with the API standard 650. Appendix E. Analyze the flexible above ground pipelines using technicals to account the harmonic response. 220 structural design all the building structural in accordance with the UFC 101-200-01. 223 the concrete when used and their unified feasibility criteria refer to the cast in place Portland cement concrete or reinforced requirements furnished and carried with the use of the coated uncoated bituminous asphalt concrete asphalt or shortcrete autoclave cellular concrete in places that is prohibited. 224 airfield airspace requirements incorporate requirements airfield airspace clearance into all construction documentation work near the airfield for compliance with the UFC 26002. 225 permits. The planner and the program designer should give the consideration to acquire permits to dredging, air emissions, water discharge consideration are process the permanent and cost impacts projects to minimum permanent requirements shall impact the permit with into the attain the permanent and into the project schedule should be application be made. Chapter 3 Bulk Fuel Storage Facilities.